Today we're going to be looking at something called the heating effect. Now in the last video we learned about current and resistance. If you're unsure, you're not confident about what these mean, I advise you to go and watch that video before coming into this one. Now we need to understand that some components do not obey Ohm's law. And what that means is the voltage is not always proportional to the current. That's not true for all components. With resistors and variable resistors, they will in your questions that will always be the case. But if we look at something like a light bulb, you can see that voltage is not directly proportional to current at all. And why is this? We talked about last video. We had this wire, and we had our positive ions in the wire and electrons flowing through the wire. And we talked about how when the electrons flow, they collide with the positive ions. And that's what the resistance in the circuit is. They rub on each other. And when they collide or when they hit, there's obviously going to be friction between the positive ions and the electrons. So therefore, due to friction, heat energy is released. And in the last video we talked about the effect of temperature on resistance. As temperature increases, we know that the positive ions vibrate more. And as they vibrate, there'll be more collisions. And that makes sense if you think about it. As you move your hands, imagining these are positive ions, it's a lot easier, there's a greater chance of electrons colliding with them. So therefore the resistance increases. Now if you're supplying a current, if you supply that current for a while, you're going to get electrons colliding with the positive ions and the positive ions vibrating more, and due to friction heat is released and the positive ions vibrate even more, and the resistance increases. We saw in the last video that for constant voltage, even if you use the V equals IR formula, if this is constant, as resistance increases, the current must decrease. So therefore, current decreases. This is known as the heating effect. And this is what you'll see in components such as the light bulb. If you look at the light bulb IV characteristic, we know that, in this case I'm going to put voltage on the x-axis and I on the y-axis. We know that as we supply a greater voltage, the current will increase due to Ohm's law, but as the current increases, we know that due to heating effect, the resistance will also increase. We have seen in an IV graph like this, the gradient is equal to 1 over the resistance. So as the resistance increases, the gradient should decrease. If you look at the IV characteristic for a light bulb, you will see it looks something like this. As the voltage increases, so does the current. But due to the heating effect, the positive ions in the light bulb will vibrate more, creating greater resistance. So there gets to a point where as soon as you apply more and more voltage, the current increases by a lower and lower amount. And that's why you can see here that the gradient, which is equal to 1 over R, decreases as voltage increases. We're going to be looking at some of the more complex circuit components that you might come across in your exams. And the first one is a thermistor. And it's denoted with this sort of circuit symbol. What's special about a thermistor is as temperature increases, its resistance decreases. This is because in a thermistor, as temp increases, bonded electrons become delocalized. And if you increase the number of electrons flowing through, you increase the charge and therefore you increase the current. So therefore the current increases, and you know V equals IR. Current and resistance are inversely proportional, so therefore the resistance decreases. Now, you probably don't need to know this explanation in your exam, and they probably won't ask you for it, but it's good to know. What this means is if you look at a resistance versus temperature graph, temperature on the x-axis, resistance on the y-axis, you'll notice it looks something like this. As temperature increases, the resistance decreases. And as temperature gets lower, the resistance actually increases. Now the next component is something called an LDR, and this is almost identical to the thermistor, except the thermistor is to do with temperature, whereas an LDR is to do with light intensity. So in this case, as if you were to plot a light intensity versus resistance graph, light intensity, resistance, you'll get the exact same graph, but you just have light intensity. As light intensity increases, the resistance decreases, and vice versa. As light intensity decreases, resistance increases. There are a couple other circuit components that are worthwhile knowing about, but they aren't usually assessed. One is the semiconductor. And a common type of semiconductor is something called a diode. And it has this circuit symbol. One big feature of a diode is that it's known to only let current in one direction, and that direction is the point in which this sort of triangle is pointing. So you can see it's pointing to the right in this case. So it only really lets current to flow in that direction. And that's because inside this diode there's a tiny vacuum. So that means that electrons would need a lot of energy, so that means a high voltage, to jump the vacuum. So if you were to look at a diode graph in terms of voltage against current, or current against voltage, you'll see it will look something like this. This here is the threshold voltage, or the breaking voltage. Let's call it Vmin. And for a silicon diode, it's roughly equal to 0.7 volts. You'll notice on the other side that it does actually let current through, but the voltage required for this is quite high, maybe around 50 volts. Might be worth having a look at what that voltage is, but you would need a very, very high voltage compared to the voltage on this side to allow electrons to flow through. But you can see here that once you pass that voltage on either side, let's look at this 0.7 volts, once you pass that, the resistance of the diode is very, very small, so it allows a lot of current to flow through. Diodes can be particularly helpful in circuits because they allow current to flow through in one direction, but will help stop it from flowing in the other. As in this case, you need a very high voltage in order to allow current to flow in the opposite direction. Now, the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.